The universe is mostly substance. It is a vast, endless ocean of velvet black, stretching out in every direction further than the human mind can truly comprehend. To the naked eye looking up from the surface of the Earth, the night sky seems frozen. The stars appear as fixed points of light, diamond dust scattered across a dark canvas. We are taught that space is a vacuum, cold and empty, where nothing changes quickly. We think of it as a graveyard of ancient lights. But this stillness is a lie. If you know where to look, and more importantly how to look, the darkness is alive. It is breathing. It is full of violent winds, invisible storms, and silent explosions that ripple through the emptiness. For the astronomers who spend their lives watching this deep dark, the sky is not a painting. It is a theatre. And sometimes, just when the audience thinks they know the script, the lead actor improvises. For weeks, the comet had been just another traveller. To the casual observer, it was nothing more than a faint smudge against the background stars. It was a dirty snowball, a mountain of ice and rock tumbling through the void, falling toward the sun. It had a name, a number, and a predicted path. It was behaving exactly as the math said it should. It was a routine object in a routine orbit, quietly melting as it got warmer, releasing a steady, predictable cloud of dust. Then came November 10th. On Earth it was a Sunday. In the quiet control rooms and home offices where astronomers interpret the whispers of the universe, the date was about to become a marker in history. The Virtual Telescope Project, a powerful set of robotic eyes that scan the heavens while the world sleeps, was tracking the comet. The telescopes swiveled silently, their motors humming, locking onto the coordinates. They opened their shutters, drinking in the faint light that had travelled for minutes across millions of kilometres to reach the lens. The data streamed down, the image processed. At first glance, it looked like any other deep space photograph. There was the black background, the grain of digital noise, and the sharp white dots of distant stars. And there in the centre was the comet. But it was wrong. An astronomer sitting in the glow of a monitor leaned closer. They wiped their glasses, perhaps thinking it was a smudge on the screen or a glitch in the software. They zoomed in, the breath caught in their throat. The silence of the room suddenly felt very loud. Before this moment, the comet had been a simple roundish glow, a fuzzy ball of light known as the coma. But on this night, the comet had grown something new, something wild. Stretching out behind the comet was a structure that had not been there before. It was not the broad, fan-shaped tail of heavy dust that comets often drag behind them like a bride's dress. This was different. This was sharp, thin, and intricate. It was a tail made of ions gas that had been stripped of its electrons by the intense radiation of the sun and caught in the invisible magnetic winds of space. It looked like a rupture in the fabric of the night. The image from November 10th revealed a chaotic beauty. The tail was not a straight line. It was twisted, knotted, and turbulent. It looked like a stream of smoke rising from a cigarette in a drafty room, swirling and breaking apart. The structure was incredibly complex. There were knots of brighter light within the stream and breaks where the tail seemed to detach and start again. To the scientist, this was a shock. Comets are usually slow to change. They evolve over weeks or months, but this was a sudden violence. It was as if the comet had been sleeping, drifting lazily through the cold, and had suddenly been slapped awake by the solar wind. The image captured a disconnection event. This happens when the magnetic field of the sun clashes with the magnetic environment of the comet. It is a magnetic storm on a massive scale happening in total silence. The solar wind had ripped the tail away from the head of the comet, creating a visual fracture. It was a snapshot of a cosmic struggle. The beauty of it was haunting. In that monochrome image, the comet looked like a jellyfish swimming through a deep dark sea, its tentacles tangled in a current we could not see. It looked fragile yet powerful. Why was this so surprising? Because of the timing. The comet was still far from the sun. It should have been quiet. It should have been dormant. The intensity of this activity, the complexity of that twisted tail, suggested that something deep inside the comet's icy heart was reacting violently. The news began to spread across the scientific community. Emails were sent, coordinates were shared, amateur astronomers with backyard telescopes pointed their lenses toward the spot. They all wanted to see the November surprise. There is a specific emotion that comes with this kind of discovery. It is not just excitement, it is a sense of smallness. We build our models, we write our equations, we predict where the planets will be in 1,000 years. We think we understand the clockwork of the solar system. And then, a ball of ice and rock does something unpredictable, and we are reminded that we are just watchers. The image from November 10th changed the narrative. The comet was no longer just a rock following gravity. It was an active dynamic object. It was interacting with the space around it. The invisible wind from the sun was sculpting it, tearing at it, and painting complex shapes with its gas. As the day turned into night on the other side of the world, more images came in. They confirmed what the virtual telescope had seen. The tail was real, the knots were real, the comet had transformed. In the darkness of space, a drama was unfolding. The comet was shedding its sin. It was bleeding gas into the void, creating a glowing trail that told the story of the invisible forces ruling our solar system. For the astronomers, the feeling was akin to walking into a dark, empty room and suddenly hearing someone breathe. The hair on their arms stood up. The object they were tracking was not just falling, it was, awakening. The mystery deepened as they analysed the shape. The tail appeared to have a kink in it, a sharp bend that defied the smooth curves usually seen in orbital mechanics. This meant the solar wind was gusting turbulent and strong, buffeting the comet like a gale-force wind hits a ship at sea. The November surprise was not just a pretty picture, it was a warning. It was a signal that the comet was entering a volatile phase. The quiet approach was over. The interaction between the sun and the ice had begun in earnest. As November 10th came to a close, the image of that twisted, broken tail remained burned into the minds of those who saw it. It was a reminder of the elegance of the universe. Even in the harsh radiation and freezing cold, nature creates art. The ion tail was a sculpture made of gas and magnetism, fleeting and temporary. In a few days it would look different. In a few weeks it might be gone entirely, but for that one moment on that one day in November, it was perfect. The comet continued its journey, plunging deeper into the solar system, moving faster with every passing second, but now it was being watched with new eyes. The indifference of the observers was gone, replaced by a tense anticipation. The beast had woken up. The silence of space had been broken by a visual scream of light and gas. And this, everyone realised, was only the beginning. To truly understand the magnitude of this event, we must stop looking at the fading ghost in the current night sky. We must rewind the clock. We must pull our minds back from the present day and return to the end of October. Specifically, we must go to the 30th of October. This was the defining moment. In the language of astronomers, this is called perihelion. The word comes from Greek roots meaning near the sun. For the life of a comet, perihelion is the most violent, critical and dangerous event that it will ever experience. It is the precise point in the elliptical orbit where the object comes closest to the star. For months, and perhaps even millions of years, this comet had been falling. It had been falling from the frozen, silent outer edges of the solar system, a region known as the Oort cloud. It had travelled through the quiet dark, a silent mountain of ice and dust, moving through temperatures that were hundreds of degrees below zero. But as October ended, that long cold silence was shattered. The comet was no longer falling through the dark, it was falling into the fire. The Great Disappearance. As the comet rushed toward this date, a strange and frustrating thing happened. For observers on Earth, the comet vanished. For weeks leading up to this moment, astronomers with backyard telescopes and binoculars had been tracking it in the night sky. They watched it grow brighter against the backdrop of the stars. But as the comet picked up speed and raced toward the 30th of October, its path took it directly into the daylight scheme. From our perspective on the ground, the comet was moving directly next to the sun. This created a zone of blindness. The sun is a massive engine of light. It is so incredibly bright that it scatters light across our entire atmosphere, turning the sky blue and completely hiding everything else behind it. No telescope on the ground, no matter how large or powerful, could look at the comet during this phase. To point a standard telescope at the sun is incredibly dangerous. The concentrated light would destroy the sensitive sensors of the camera and could blind a human observer instantly. So just as the cosmic drama was reaching its absolute peak, humanity was forced to look away. The comet entered the solar glare. It was like watching a diver jump off a high cliff into a dark, churning ocean. You see them fall, but once they hit the water, they are gone. You can no longer help them, you can only wait for them to surface. The Lonely Watchers, Soho and Stereo. However, the comet was not entirely unobserved. While the blue skies of Earth blinded us to the drama, our mechanical eyes in space were still watching. High above our atmosphere, floating in the vacuum of space, are the solar observatories. The most famous of these is the Soho spacecraft Solar and Heliospheric Observatory, along with its partner mission, Stereo. These satellites are the sentinels of the sun. They do not blink, they do not sleep. They are built to withstand the intense radiation and the harsh environment of deep space. To see the comet next to the sun, these satellites use a very clever trick. They use an instrument called a coronagraph. Imagine holding your hand up to block the sun so you can see a plane flying near it. That is exactly what a coronagraph does. It creates an artificial eclipse inside the camera. A small metal disc blocks out the blinding central circle of the sun. This allows the camera to see the faint ghostly atmosphere around the sun known as the corona. On the 30th of October, on monitors and control rooms on Earth, the images from SOHO began to arrive. These images are not like the beautiful photographs we take on Earth. They are usually grainy black and white or false colour red and blue images. In the centre of the image is a blank black circle where the sun is blocked out. And there, entering the frame from the corner, was a small white pixelated dot. It looked tiny, it looked incredibly fragile. It was a speck of white dust flying into a furnace. This was the only visual confirmation we had. While the world went about its business on Earth, these lonely satellites watched the comet rush toward its destiny. The furnace of perihelion. We must try to imagine the physical reality of that day. The contrast is nearly impossible for the human mind to comprehend. Space is usually defined by cold. It is the kind of cold that stops atoms from moving. But at perihelion, the environment flips completely. As the comet pierced the solar atmosphere, it was subjected to heat that reached millions of degrees. This is the solar embrace. It is not a gentle hug, it is a violent attack. The comet is essentially a dirty snowball, a mixture of frozen water, carbon dioxide, dust and rock, held together by weak gravity. As it plunged closer to the solar surface on October the 30th, the heat did not just melt the ice, it caused sublimation. This means the ice turned instantly from a solid block into a gas, skipping the liquid stage entirely. Explosions of gas erupted from the surface of the comet. Jets of steam and dust blasted out into space, creating the long, beautiful tail we see in photos. But this close to the sun, those jets were like screams. The pressure was immense. The comet was losing mass at a rate of tons per second. It was being peeled apart layer by layer by the intense solar wind, a stream of charged particles shooting out from the sun. The battle of gravity and heat. The heat was not the only enemy. There was also gravity. The sun is the most massive object in our entire system. Its gravity is what holds all the planets from Mercury to Neptune in their orbits. When a small fragile object like a comet gets that close within a few million kilometers, it experiences what scientists call tidal forces. To understand this, imagine holding a snowball in your hand. Now imagine a giant invisible hand pulling on the bottom of the snowball much harder than it is pulling on the top. The snowball would stretch, distort, and eventually crack. This is what happened to the comet. The gravity of the sun pulled on the front of the comet much harder than it pulled on the back. This stretching force tried to rip the nucleus, the solid heart of the comet, into pieces. So on that day, the 30th of October, the comet was fighting a war on two fronts. On the outside, the solar wind and radiation were burning it away. On the inside, gravity was trying to tear it apart from the center. Waiting in the dark, back on Earth, the scientific community waited. The images from SOHO take time to process and download. There is a delay. The silence was heavy with anticipation. We knew the mathematics. We knew the trajectory. We knew that on that specific day, the comet was swinging around the back of the sun, hidden from view, even for the satellites for a short time. It was a moment of pure suspense. Would the comet survive? Many comets do not. These unfortunates are known as sun grazers. They fly too close and the heat and gravity completely destroy them. They simply evaporate, turning into a cloud of dust that drifts away into nothingness. They enter the furnace and never come out. We waited to see if a white dot would emerge from the other side of the black disk on the SOHO screens. We waited to see if the structure would hold together. This is the emotional core of perihelion. It is a test of endurance. It is a tiny ancient piece of the universe formed at the very beginning of time, facing the creator of our system. It is a confrontation between the cold preserver of history, the comet, and the hot destroyer of matter, the sun. As the hours of October 30th ticked by, the comet was hidden in the glare, enduring the ultimate trial by fire. It was alone in the blinding light, stripped of its protection, fighting to stay together as it whipped around the star at speeds of hundreds of thousands of kilometers per hour. We could only watch the satellite feeds and hope that anything would survive the journey to return to the cold safety of deep space. To understand why the comet seemed to appear out of nowhere, we have to stop looking at the sky as a flat painting. We must start thinking of it as a three-dimensional map. The reason we could not see the magnificent tail earlier was not because the tail did not exist. It was there, stretching out for millions of kilometers into the deep darkness. The problem was not the object itself. The problem was where we were standing. It was a trick of geometry, a grand illusion caused by our position in the solar system. Imagine for a moment that you are standing on the side of a long, lonely highway in the middle of the night. The air is thick with a heavy damp fog, it is pitch black, and you are waiting for a car to approach from the distance. As the car comes over the horizon, driving straight toward you, what do you see? You see two blinding points of light. The headlights are intense and painful to look at. They wash out everything around them. Because the car is facing you directly, you cannot see the beams of light themselves. You cannot see how far the light stretches, or the shape of the cone it cuts through the fog. You only see the glare. The light is fighting against you, blinding your vision, hiding the details in a wash of white. This is exactly where the comet was in relation to Earth for a long time. It was positioned somewhat between us and the Sun. When we tried to look for it, we were looking into the headlights of the solar system. The Sun's glare was too powerful and the angle was wrong. The sunlight was hitting the front of the comet and bouncing back toward the Sun, leaving the side facing Earth mostly in shadow or lost in the brilliance of the twilight. We were blinded by the glare, unable to see the structure of the tail. Now go back to that dark highway. Imagine the car does not hit you, but instead it begins to turn. It takes a wide curve and drives past you, moving away into the distance. This is the moment everything changes. As the car turns its side to you and the headlights point away from you and into the fog, something magical happens. You no longer see the blinding glare of the bulbs. Instead, you see the beam itself. The light catches the billions of tiny water droplets in the fog. Suddenly, the empty air lights up. You can see a long defined cone of light stretching out from the car, cutting through the darkness like a solid object. This phenomenon is what scientists call forward scattering. It happens when light passes through particles like fog smoke or dust and is scattered toward the observer. It makes the dust glow with an intense ghostly brightness. This is what happened with the comet. This is the geometry problem being solved. As the comet rounded the Sun and began its journey back out toward the edge of the solar system, and as Earth continued its own silent orbit around the star, the angles shifted. We were no longer staring into the headlights. We were no longer standing directly in the path of the glare. Slowly, day by day, the geometry aligned. The comet moved into a position where the Sun was behind it relative to our view or to the side. The sunlight began to stream through the dusty tail of the comet, acting just like the car headlights beaming through the fog. The tail is made of fine dust, tiny grains of rock and ice left behind as the comet melts. When the sunlight hits these tiny grains from the back, they scatter, the light forward toward our eyes and our cameras. This backlighting effect amplifies the brightness of the tail dramatically. It turns a faint dusty streak into a glowing, radiant sword of light. This shift in perspective explains the sudden majesty of the view. The tail had been growing for months. It was quietly expanding, releasing tons of dust every second as the heat of the Sun boiled the comet's icy surface. But without the right angle, without the side view that allows for that scattering of light, it remained a secret. It was hidden in plain sight, waiting for us to move to the right seat in the cosmic theatre. There is a profound lesson in this celestial mechanics. It reminds us that our perception of reality is entirely dependent on where we are standing. The universe does not change just to please us. The comet does not decide to become beautiful for our benefit. The beauty was always inherent in it. It was the chaos of the dust and the violence of the solar wind. But we could not perceive it until we had the patience to wait to drift through space until our viewpoint matured. For astronomers and skywatchers, this period required immense patience. They knew the math, they knew the comet was there surviving its close encounter with the fire of the Sun. But knowing it is there and seeing it with your own eyes are two very different experiences. They had to wait for the Earth to rotate and orbit enough degrees to unlock the view. It is a slow, silent drama. In our modern world, we are used to things happening instantly. We want the video to load the message to send the lights to turn on immediately. But the sky operates on a different clock. It operates on the scale of millions of kilometers and thousands of years. To see the tail, we had to wait for the planetary alignment. We had to wait for the sunset to be just right for the geometry of three moving bodies, Earth, Sun and Comet, to form a perfect triangle in the void. When you look at that tail now stretching across the western horizon, remember the car in the fog. You are seeing sunlight that has travelled 150 million kilometres, hit a tiny grain of ancient dust and bounced off it to travel another 70 million kilometres to hit the retina of your eye. You are seeing the structure of the solar wind itself illuminated by the backlight of our star. The tail looks solid like a white brushstroke on a canvas, but it is actually incredibly thin, a vacuum filled with ghosts of ice and rock. It is the angle that gives it substance. So the illusion of sight is broken not by force but by movement. We simply had to move. We had to shift our perspective to see the truth of what was happening in the dark. The comet was never hiding. We just had to find the right place to stand to see it shine. By the time we reached the 10th of November, the image captured was no longer just a picture of a celestial object. It had become a portrait of physics in motion. When we look closely at the photograph from this specific night, we are not seeing a static painting. We are witnessing a moment frozen in time, a snapshot of a violent yet silent interaction between the Sun and the comet. The most striking feature that draws the eye immediately is the ion tail. Unlike the broad, diffuse dust tail that spreads out like a fan, the ion tail is straight, narrow, and filled with an incredible amount of internal structure. It looks less like a cloud and more like a bundle of glowing threads tightly wound together. This is where the metaphor of weaving becomes literal. On this date, the photograph reveals that the tail is not a solid beam of light. Instead, it is composed of many individual filaments, often called streamers. These streamers look like fine hairs or the strings of a harp running parallel to one another. Each streamer is a tube of gas electrically charged by the intense ultraviolet light from the Sun. They cluster together, weaving in and out of the main flow, creating a texture that makes the tail look three-dimensional, almost like a braid of fabric stretching across the stars. The colour of this structure is profound and scientifically significant. While the dust tail reflects the warm yellowish-white sunlight, the ion tail glows with a distinct electric blue or teal colour. This is not a reflection. It is fluorescence. The comet is essentially acting like a giant neon sign. The gas being stripped away from the nucleus consists largely of carbon monoxide. When the harsh light of the Sun hits these carbon monoxide molecules, it knocks electrons loose, creating ions. When these ions capture electrons back or interact with sunlight, they glow with that specific blue-green wavelength. On the night of November 10th, the contrast between this electric blue stream and the deep black background of space was at its peak, making the delicate internal structures visible to the camera. As we trace the length of these streamers, we can see the invisible hand of the Sun at work. The Sun does not just emit light, it constantly blows a stream of charged particles outward in all directions, known as the solar wind. This wind moves at incredible speeds, hundreds of miles per second. The comet's ion tail is caught in this wind like a windsock at an airport. This is why the ion tail always points directly away from the Sun, regardless of which direction the comet is actually travelling. The solar wind acts like a comb, straightening out the tangled gases from the comet's head and forcing them into these long straight lines. However, on November 10th, we can see that the lines are not perfectly straight. There are subtle waves and kinks in the tail. These imperfections are the most fascinating part of the anatomy. They reveal the turbulence of the solar wind. Just as a flag flutters and snaps in a stiff breeze on Earth, the ion tail ripples in the magnetic currents of the solar wind. If you look very closely at the high-resolution image, you might see a disconnection event, or a knot in the tail. This happens when the magnetic field lines carried by the solar wind clash with the magnetic field created around the comet. It can cause a piece of the tail to pinch off and drift away, only for a new tail to instantly begin growing to replace it. It creates a sense of motion and drama, showing us that the environment of space is not empty, but filled with invisible forces pushing and pulling on the matter. The weaving effect is also enhanced by our perspective from Earth. Because we are looking at a three-dimensional object projected onto a two-dimensional sky, the streamers appear to overlap. Some are in the foreground, some in the background. This layering creates areas of greater brightness where the gas is denser, or where two streamers line up from our point of view. It gives the tail a ribbed appearance like the spine of a deep-sea creature. The light seems to pulse and vary along the length of the tail, fading out gently into the darkness the further it gets from the comet's head. There is a beautiful delicacy to the edges of the ion tail. It does not have a hard boundary. Instead, the electric blue light feathers out, becoming fainter and fainter, until it becomes indistinguishable from the background noise of the universe. This gradient suggests the diffusion of the gas. As the ions travel down the tail, they eventually disperse, spreading out into the vacuum. The image captures this transition perfectly, the journey of matter, from a frozen rock to a glowing, dense stream, and finally to scattered atoms lost in the vastness of the solar system. What makes the view from November 10th particularly special is the separation between the ion tail and the dust tail. We can see the two distinct components diverging. The heavy dust particles are left behind in the comet's orbit, curving gently, while the light ions are pushed hard and fast by the solar wind. The space between them is not empty. It is filled with a mix of faint material, creating a V shape that frames the stars behind it. The ion tail serves as the sharp defining line of this composition, cutting through the star field with geometric precision, while the dust tail adds a soft, painterly wash of light. Emotionally looking at this anatomy evokes a sense of fragile beauty. We know that what we are seeing is incredibly tenuous. The gas in that tail is a nearly perfect vacuum by Earth standards, yet it glows so brightly because of the sheer scale of the comet and the energy of the sun. It is a ghostly apparition. The dance of these particles is a reminder of the connection between all things in the solar system. The comet reacts to the sun, the tail reacts to the wind, and the light travels across millions of miles to be caught by our cameras. The image is a testament to the complexity of nature. It shows us that even in the cold void there is structure, there is colour, and there is distinct organisation. The streamers do not just chaotic fly apart, they follow the magnetic highways of the solar system. To view the ion tail on this night is to see the magnetic field of the sun made visible, painted in blue light by the dying breath of a travelling ball of ice. It is a loom of light weaving a temporary tapestry that will dissolve as quickly as it formed, leaving only the memory of its elegance on the digital sensors of our telescopes. The story of Oumuamua is usually told through its shape or its speed, but the true ghost in the machine, the detail that kept astronomers awake at night, was found in the raw data of its light. To understand the mystery, one must first understand the darkness from which it came, and the standard expectations we hold for objects travelling through our solar system. When a rock or a ball of ice falls toward the sun, we expect it to behave according to the strict, predictable laws of physics. We have a standard mathematical model for this. Usually as an object gets closer to the sun, it gets brighter because it reflects more sunlight. This is often described by a specific rule where the brightness increases based on the distance to the sun raised to the power of -4. This power of -4 is the baseline. It represents a passive object. It implies that the object is simply acting like a mirror, reflecting the sunlight that hits it, perhaps aided by a little bit of fluorescence from surface gases. It is a steady, reliable climb in luminosity. As Oumuamua pierced the inner solar system, telescopes tracked its brightness curve, expecting it to follow this gentle slope. But the data refused to cooperate. Instead of a steady climb, the brightness surged. It did not follow the rule of -4. Instead, the data points plotted a much steeper, more aggressive curve closer to the distance raised to the power of -7.5. To put this in perspective, the difference between a power of 4 and a power of 7.5 is not a minor statistical error. It is the difference between a gentle hill and a vertical cliff. This was not just a rock reflecting light. This was an object that was actively responding to the solar environment. The surge in brightness suggested that Oumuamua was not merely a passive traveller, it was waking up. The sheer intensity of the light coming from such a small distant point indicated that the surface area capable of reflecting light was effectively increasing, or rather that the object was generating a cloud that caught the sunlight much more effectively than the solid surface alone could. This brings us to the violent elegance of sublimation. In the deep freeze of interstellar space where Oumuamua had spent the last few billion years, temperatures hover near absolute zero. In that state, water, carbon dioxide and carbon monoxide are not liquids or gases. They are rock-hard solids frozen into the very matrix of the object. They are sleeping energy. However, as Oumuamua rushed toward our sun, the heat began to penetrate its crust. This is where the power of -7.5 finds its physical explanation. The heat did not just warm the rock, it triggered a phase change. The surge in brightness was likely caused by the sudden intense sublimation of volatile ices. Unlike water ice, which requires a fair amount of heat to turn into gas, supervolatiles like carbon monoxide or pure nitrogen destabilize very quickly. They do not melt into liquid, they explode directly from a solid into a gas. This process creates a temporary atmosphere, a coma that expands around the object. Even if this coma is thin, it dramatically increases the cross-section that can scatter sunlight. The surge in the data was the signature of this invisible cloud. It was the visual evidence of the object sweating its ancient reserves of ice into the vacuum, creating a halo that, while perhaps invisible to the naked eye, shone brilliantly to our senses. There is a profound emotional weight to this mechanism. We are witnessing a silent explosion. For eons, these chemical compounds have been locked in the dark, preserving the chemical fingerprint of the star system where Oumuamua was born. The surge in brightness was the release of that ancient breath. It was the object shedding its skin, sacrificing its own mass to survive the thermal shock of our sun. It speaks to the internal energy of these celestial wanderers, They are not dead rocks, but dormant chemical engines waiting for the trigger of a star's warmth to roar back to life. However, this release of gas leads to a common misconception that must be corrected specifically regarding the colour of Oumuamua. In popular media and artistic renderings, this phase is often depicted as the surface itself changing colour, perhaps glowing red-hot or shifting hues like a mood ring. This is a misunderstanding of the data. When astronomers speak of colour change in this context, they are not referring to the physical paint of the surface, but rather to the spectral properties of the light being reflected. The human eye might have just seen a reddish, tumbling needle, but the instruments were looking at the spectrum, the rainbow fingerprint of the light. The colour change was actually a shift in the ratio of different wavelengths of light. As the gases sublimated the carbon dioxide, the water, the organics, they interacted with sunlight. Different molecules absorb and re-emit light at very specific frequencies. The red we talk about is largely due to the presence of complex organic molecules on the surface tholins, which are created when cosmic rays bombard simple ices over millions of years. But the change in that colour profile as it neared the sun was the result of the coma, the gas cloud altering the light signature. It wasn't that the rock turned green or blue, it was that the gas cloud surrounding it filtered the sunlight differently than the bare rock did. It is a distinction of chemistry, not pigment. We were seeing the spectral signature of gas being liberated. We were seeing the colour of the vacuum being filled with new molecules. It is a reminder that in astronomy, beauty is often found not in what we can see with our eyes, but in the chemical stories told by the breakdown of light. This correction adds to the mystery rather than subtracting from it. If the object was releasing enough gas to cause such a massive surge in brightness following that steep negative 7.5 power law, why didn't we see a massive tail like a traditional comet? Usually this amount of outgassing drags dust with it, creating a visible tail that stretches for millions of miles. Oumuamua had the gas implied by the brightness and the acceleration, but it had no dust. This suggests a unique structure. Perhaps the surface was a distinct crust of dried, organic-rich material that held together while the gases shot out through specific vents or fissures, pure and dust-free. Or perhaps the object was made of monolithic ice that sublimated cleanly, leaving no dusty skeleton behind. Ultimately, the brightness anomaly is a story of resilience and reaction. It transforms Oumuamua from a piece of debris into a dynamic participant in its journey. It reacted to our sun. It felt the heat and responded with a surge of activity that defied our standard models. It reminds us that the universe is not filled with static dead things, but with chemically complex entities that carry the frozen history of their birth within them. When we looked at that spike in the brightness graph, we were not just seeing light. We were watching the heart of a distant dead solar system beating one last time as it warmed itself by our fire. The steepness of that curve is the measure of its alien nature, a testament to a composition that we are still struggling to fully comprehend. When astronomers look up at the night sky, they expect a certain level of order. For centuries, we have relied on a very specific set of rules to predict the motion of the heavens. The most important of these rules is gravity. In the vast, silent theatre of our solar system, gravity is usually the only director. It tells the planets how to orbit it, commands asteroids to drift in specific lanes, and it dictates exactly when comets will swing back around the sun. When Oumuamua was first spotted, the scientific community assumed it was just another rock obeying these standard orders. Astronomers calculated its future path based entirely on the gravity of the sun. They drew a mental line through the solar system expecting the object to follow it perfectly. But Oumuamua did not follow the line. As the days turned into weeks and the data accumulated, a strange discrepancy began to appear. The object was not where it was supposed to be. It was slightly ahead of schedule. It was moving faster than it should have been if gravity were the only force touching it. In the precise world of orbital mechanics, even a tiny difference is a loud alarm bell. It meant that gravity was not acting alone. Something else was pushing it. This phenomenon is what scientists call non-gravitational acceleration. To understand this, we have to look at the most basic laws of motion formulated by Isaac Newton hundreds of years ago. Newton taught us that for every action there is an equal and opposite reaction. This is the secret behind how rockets fly. A rocket shoots hot gas out of its back at high speed. That is the action. The reaction is that the rocket gets pushed forward. In nature, comets act exactly like natural rockets. We call this the rocket effect. A comet is essentially a dirty snowball floating in the void. As it travels from the freezing dark of deep space and gets close to the sun, the intense heat warms up its surface. The ice on the comet does not melt into water, it turns instantly into gas. This process is called sublimation. When this gas shoots off the surface of the comet, it acts just like the exhaust of a rocket engine. It gives the rock a gentle but persistent kick, pushing it in the opposite direction. This was the leading theory to explain why Oumuamua was moving so strangely. The astronomers believed it was simply outgassing. It was being pushed by its own evaporating ice. David Finocchia, a brilliant navigation engineer at NASA's Jet Propulsion Laboratory, was one of the key figures deeply involved in solving this puzzle. He is an expert in calculating the trajectories of objects in space. Finocchia and his team looked at the numbers with incredible precision. They realized that the extra speed Oumuamua possessed was very small, but it was undeniable. Finocchia's calculations showed that this push followed a very specific pattern. The force was strongest when the object was closest to the sun, and it got weaker as the object moved further away. This fit the profile of a comet perfectly. The closer you are to the heat source, the more ice turns to gas, and the stronger the rocket effect becomes. It seemed like the mystery was solved. Oumuamua was a comet disguised as an asteroid getting a boost from evaporating sunlight. However, this explanation gave birth to a new, much deeper mystery. This brings us to the arguments raised by Professor Avi Loeb. While Finocchia's math correctly described how the object moved, Loeb argued that the physical reality of the object did not make sense with that math. The problem was visibility. If a comet is outgassing enough to change its course, we should see it. When ice turns to gas, it usually carries dust with it. This dust reflects sunlight, creating the beautiful glowing tail we associate with comets. But Oumuamua had no tail. It had no cloud of gas around it known as a coma. Deep space images showed it as a single sharp point of light. Furthermore, the Spitzer Space Telescope, which looks at the universe in infrared or heat light, pointed directly at Oumuamua. It looked specifically for carbon-based gas or dust. It found absolutely nothing. The object appeared to be completely dry and dead. This led to a heavy debate regarding the mass of the object. To push a rock the size of a football field, you need a significant amount of force. Avi Loeb pointed out a critical issue with the rocket effect theory in this specific case. He calculated how much ice would need to evaporate to generate the speed boost that Finocchia observed. The numbers were staggering. For the rocket effect to be the answer, Oumuamua would have needed to burn through a massive amount of its own material. Loeb argued that to achieve that specific acceleration, the object would have to lose approximately 10% of its total mass. Imagine a runner sprinting down a track. Now imagine that to run slightly faster, the runner had to shed 10% of their body weight in sweat and energy in just a short time. That is a violent, dramatic change. If Oumuamua had lost 10% of its mass in the form of gas and dust, the result should have been spectacular. It should have created a cloud of particles bright enough to be easily seen from Earth. It would have been a clear, undeniable comet. Yet the sky remained dark. Loeb's argument was simple but powerful. You cannot have it both ways. You cannot have a rocket powerful enough to push a massive rock but invisible enough that our best telescopes see nothing. If the gas was there, we should see it. If the gas was not there, what was pushing the object? This created a split in the scientific narrative. On one side, there was the mainstream scientific view supported by researchers like Finocchia. They argued that perhaps Oumuamua was a weird type of comet. Maybe it was releasing a type of gas that our telescopes could not see, like pure water vapor with no dust. Maybe the dust grains were too large to reflect light in the way we expect. They believed the trajectory proved it was natural even if its appearance was unusual. On the other side, Loeb argued that the laws of physics were suggesting something else. He believed that natural explanations were failing to account for the combination of the acceleration and the lack of a tail. He suggested that if the push was not coming from a rocket engine of gas, perhaps it was coming from the reflection of sunlight itself, solar radiation pressure. But for sunlight to push a rock that hard, the rock would have to be incredibly thin, lightweight and broad. That, however, leads us toward the concept of artificial origins. For now, we remain in the uncomfortable silence of the void. We are left with an object that obeys the laws of Newton, but refuses to show us its engine. We see the effect the invisible hand pushing Oumuamua away from the sun, but we cannot see the cause. It's a reminder of how subtle space can be. We often think of space events as violent explosions or crashing asteroids, but here the drama was in the decimals. It was a tiny, gentle deviation in a line of numbers. a silent, invisible breath that nudged a traveller off its expected path, sparking a debate that would question our understanding of what exists in the dark spaces between the stars. If you were to look up at the night sky tonight and find this dying giant, it would greet you with the same steady ruby-red glow it has offered for centuries. To the naked eye, it is a picture of absolute stability. It is a lighthouse that refuses to dim. However, the mathematics of the star tells a violent, desperate story that our eyes cannot see. There is a profound contradiction here, a paradox that often confuses students of astronomy. The calculations derived from the laws of thermodynamics and gravity insist that the star is bleeding. It is losing mass at a rate that defies human comprehension. Every single year, this star sheds an amount of material roughly equal to the mass of the entire Earth multiplied by millions. In the time it takes you to read this sentence, the star has ejected billions of tons of gas into the void. So how can something lose so much of itself and yet appear to remain exactly the same size and brightness to us? Where is all that matter going, and why can we not see it happening? The answer lies in the grandest illusion of the cosmos, the vanishing act of diffusion. To understand this, we must look at what mass loss actually means for a red supergiant. It is not losing chunks of itself like a crumbling cliff falling into the sea. It does not break apart in solid pieces. Instead, the star is exhaling. It is breathing out a constant heavy wind of gas and microscopic dust. Imagine a pot of boiling water. When the steam rises, you can see it clearly right above the surface of the water. It is thick, white and opaque. But as that steam rises higher into the kitchen, it spreads out. It mixes with the air. Suddenly, the steam becomes invisible. It is still there. The water molecules are floating around you, increasing the humidity of the room. But because they have spread out, your eyes can no longer register them as a cloud. This is exactly what is happening to the star, but on a scale that is terrifyingly vast. The material leaving the star is ejected at speeds of thousands of miles per hour. As this gas travels away from the surface, it enters the absolute vacuum of space. Space is hungry. It is an endless container waiting to be filled. The gas expands rapidly to fill this void. As it expands, its density drops precipitously. By the time this ejected material has traveled a distance equal to the reach of our own solar system, the atoms are so far apart that they become optically transparent. To our eyes, and even to standard optical telescopes, the gas has simply vanished. It has become a ghost. It creates a massive invisible shell around the star, hiding in plain sight. This leads us to the limitation of our own perception. Human vision is an evolutionary tool designed for survival on the Earth under the light of our sun. We are evolved to see visible light, a very narrow slice of the electromagnetic spectrum. We see things that are hot and bright or things that reflect sunlight. The dust and gas expelled by the dying star are neither hot enough to glow brightly in visible light nor dense enough to reflect the star's light effectively back to us. As the gas expands, it cools down drastically. It becomes cold hundreds of degrees below zero. Cold things do not shine in the way our eyes expect. They do not emit the yellow or red light we can see. Instead, they emit weak infrared waves and radio waves. Therefore, when we look at the star, we are blinded by the contrast. The center of the star, the photosphere, is still a raging nuclear furnace shining with the power of 100,000 suns. It is dazzlingly bright. Surrounding this bright bulb is the cold, thin, expanding smoke of its own death. It is the equivalent of trying to see a puff of cigarette smoke next to a high-powered stadium floodlight aimed directly at your face. The glare of the light completely washes out the smoke. The smoke is there, but the brilliance of the source makes the surrounding environment look empty. Modern astronomy has allowed us to peel back this layer of illusion, but only by abandoning our human eyes. When scientists point infrared telescopes at these stars, the picture changes dramatically. In the infrared spectrum, the glare of the star is dimmed, and the cold dust begins to glow. Suddenly, the darkness around the star lights up. We see that the star is not a lonely dot in black space. It is actually the center of a massive chaotic storm. We see arcs of gas shells of dust and great plumes of matter stretching out for trillions of miles. We realize that the star is significantly larger than it appears. The empty space around it is actually a graveyard of discarded matter, a physical record of the star's history, layer upon layer of ejected skin. This reality creates a humbling emotional realization about the nature of the universe. The vastness of space is so overwhelming that it can swallow entire planets' worth of matter and make it look like nothing. We tend to think of reality as what we can see and touch. If we cannot see the wall, we assume there is no wall. But the story of the dying star teaches us that most of the universe is hidden from us, not because it is magical, but because it is diffused. The matter is there, drifting in the dark, waiting to be recycled into new stars, new planets, and perhaps new living things eons from now. The mass loss paradox is not a failure of the star, it is a failure of our perspective. The star is dissolving, it is sacrificing its body to the void, transforming from a singular bright object into a vast invisible nebula. We are witnessing a slow-motion magic trick where the magician does not disappear into a trapdoor, but rather dissolves into the air itself, atom by atom, until only the memory of the light remains. The star is becoming a ghost while it is still alive, its substance spreading so thin that it merges with the silence of the cosmos, leaving us to wonder where the giant went even as we stare directly at it. In the vast, silent expanse of our solar system, coincidence is a rare and beautiful thing. Space is defined largely by its emptiness. It is a void so wide and so deep that objects are usually separated by millions of kilometers of nothingness. When we launch a machine from Earth, we calculate its path with agonizing precision, threading a needle across a distance so vast the human mind struggles to comprehend it. Usually these paths are lonely. A spacecraft travels alone, speaks only to Earth, and focuses entirely on a destination years away. But occasionally the universe offers a gift. It provides a moment of serendipity, a happy accident where paths cross in the dark. This is the story of the spacecraft Hera and Europa Clipper, and their unexpected encounter with the ghostly remains of Comet Atlas. To understand the beauty of this moment, we must first look at the travelers. First, there is Europa Clipper. This is a giant of a machine, the largest spacecraft NASA has ever built for a planetary mission. Its massive solar arrays stretch out like the wings of a great bird designed to catch the faint sunlight near Jupiter. Its destination is Europa, an icy moon that hides a liquid ocean beneath its crust. Clipper is a seeker of life potential, a scientific vessel bound for a world of water and ice. It launched in October of the year 2024, beginning a journey that will take years to complete. Almost simultaneously, another traveller left Earth. This was Hera, a mission by the European Space Agency. Hera is a detective. His job is to return to the scene of a cosmic crime, the double asteroid system of Didymos and Dimorphos. A few years ago, humanity intentionally crashed a probe into Dimorphos to see if we could move an asteroid. Now Hera is flying there to investigate the crater, to measure the mass and to see exactly what happened. 2 different ships, 2 different destinations, 2 different agencies, yet they launched into the same sky during the same window of time, heading out into the cosmic ocean. And then there was the third player in this drama, Comet Atlas. Comet Atlas was a visitor from the very edge of the solar system, from the Oort cloud. It was a ball of ancient ice and dust that had been falling toward the sun for thousands of years. Astronomers had high hopes for Atlas. They hoped it would become the comet of the century, blazing bright enough to be seen during the day. But comets are fragile things. As Atlas drew close to the searing heat of the sun, the gravitational forces and thermal stress were too much. The comet crumbled. It fragmented. It did not become a bright beacon, but rather a ghost, a spreading cloud of gas dust and charged particles, in a twist of orbital mechanics that no one had planned years in advance. The trajectories of Hera and Europa Clipper were set to cross through the region of space where this comet's tail was drifting. This was not a collision in the dramatic Hollywood sense. Space is too empty for that. The spacecraft were not dodging giant rocks or tumbling through a storm of fire. Instead, they were passing through a wake, much like a small boat crossing the ripple left by a ship that passed hours ago. The tail of a comet is a tenuous thing. It is made of gas that has boiled off the comet's surface and dust grains that are finer than talcum powder. It also contains plasma gas that has been electrified by the sun. To the human eye, if you were floating next to Hera or Clipper, you might not see anything at all. The space would still look black and starry. But to the sensitive instruments on board these machines, the environment was rich with information. Imagine the scene. These 2 robotic explorers are millions of kilometers from home. They are drifting through the silence. Suddenly their sensors pick up a change. For Europa, Clipper designed to survive the intense radiation belts of Jupiter, this was an unexpected warm-up exercise. As dust detectors, which are meant to taste the icy spray of Europa's geysers, began to register hits. These were not violent impacts, but microscopic pings. Tiny grains of dust left behind by the crumbling comet struck the spacecraft's sensors. Each ping was a piece of data. Each grain told a story of the comet's composition. What was this comet made of? Was it water ice, carbon dioxide, organic molecules from the birth of the solar system? Simultaneously, Hera was flying through a similar stream. Hera is equipped with instruments to measure the space environment around asteroids. As it passed through the comet's wake, it could sense the magnetic disturbance. A comet interacts with the solar wind, the stream of particles flowing from the sun. It creates a ripple in the magnetic field of the solar system. Hera, floating through this invisible river, became a witness to the comet's dying breath. There is a profound emotional weight to this event. We often think of our machines as cold, unfeeling metal, but in moments like this, they feel like extensions of ourselves. They are our eyes and ears in the dark. Think of the loneliness of these ships. They are sailing the void, moving at speeds of tens of thousands of kilometers per hour. They are so far away that even light takes minutes to travel from them to Earth. And yet in the middle of this isolation, they found a connection. They connected not with each other physically, but through a shared experience. They both dipped their toes into the same river of cosmic dust. It is a meeting of ships in the night. Hera and Europa Clipper did not see each other. They did not wave, but for a brief period they were united by the presence of Comet Atlas. This opportunity allows scientists to do something they rarely can: cross-calibration. By having two different spacecraft with two different sets of instruments measuring the same event from slightly different locations, we get a stereo view of reality. It turns a flat image into a three-dimensional map. It helps us understand the structure of a comet's tail in a way that a single spacecraft never could. We usually spend decades planning missions to intercept comets. We spent years building the Rosetta spacecraft just to catch Comet 67P. We built Stardust to catch samples from Comet Wild 2. These missions cost billions of dollars and take lifetimes of work. But here, the universe gave us a free Comet mission. We did not have to change the course of Clipper or Hera. We did not have to spend extra fuel. The geometry of the heavens simply aligned in our favor. It's a reminder that while we can calculate orbits and plan trajectories, the universe still holds surprises. It reminds us that space is dynamic. It is not a static painting, but a moving, breathing environment. Comets die and leave ghosts behind. Solar winds blow like gales across the void. And our little metal ships, brave and fragile, sail through it all, collecting the whispers of the cosmos to send back home to us. As Hera and Europa Clipper continue their separate journeys, one to the asteroid graveyard, one to the kingdom of Jupiter, they carry with them the memory of this crossing. They carry the microscopic dust of a traveller that came from the edge of the solar system and perished in the heat of the sun. It is a poetic convergence, the machine built to look for life, Clipper, the machine built to protect life on Earth, Hera and the dying celestial wanderer Atlas, all meeting for a brief moment in the silent velvet dark of deep space. It gives us hope that as we venture further out, we will find not just empty space, but a universe that is rich, interconnected, and waiting to be understood. The silence of the void is not truly empty, it is full of stories written in light. As our instruments stare at the dark surface of 3i Atlas, we are no longer just looking at a rock. We are reading a diary that has been closed for 4.5 billion years. To understand where this traveller came from, we have to look at how it touches the sunlight. This is the study of polarization. When light from the sun hits the surface of Atlas, it does not bounce back evenly like a reflection in a mirror. It scatters. It gets twisted and turned by the landscape it strikes. By measuring the angle and the intensity of this scattered light, we can feel the texture of the surface without actually landing on it. The data coming back is haunting. The polarization signature tells us that the surface of Atlas is incredibly porous. It is not a solid, dense stone like a river pebble. Instead, it is fluffy and fragile, somewhat like the ash from a fire or dry, powdery snow. This texture is a critical clue. It tells us that the surface has likely remained undisturbed since the very dawn of its creation. It has not been packed down by gravity, melted by heat, or smoothed by wind. It is a pristine archive of the past. This specific way the light behaves suggests a surface covered in grains of dust that are larger than the wavelength of visible light, yet arranged in a structure that is 90% empty space. It is a structure often called a fairy castle, delicate and dark. This confirms our suspicions that Atlas is not a fragment broken off from a collision between two planets. It is a primordial building block. It is a seed that never had the chance to grow into a world. Beneath this dark, fluffy crust lies the chemical truth of its home. Our spectrometers have been dissecting the faint glow of the object, hunting for the fingerprints of elements. We found them, and they speak of a freezing ancient cold. We detected strong signatures of carbon-rich compounds and water ice, but not the kind of ice we find in our drinks. This is amorphous ice water that froze so instantly in the deep vacuum that its molecules never had time to arrange themselves into crystals. Alongside the water, we found traces of carbon monoxide and carbon dioxide frozen solid. This chemical recipe is the key to the map. Carbon monoxide is very volatile. It turns into gas at extremely low temperatures. For Atlas to hold onto this ice for so long, it must have formed in a place of absolute crushing cold. It could not have been born near its star. It was born in the shadows far beyond the snow line of its home system. Imagine a young star billions of years ago. Surrounding it is a vast swirling disk of gas and dust. Close to the star it is hot and only rock and metal can survive, but far out where the star is just a bright point in the darkness, the gases freeze. This is the nursery of comets and ice dwarfs. This is where Atlas was born. It was a quiet, crowded region. Trillions of icy crumbs were slowly coming together, gently sticking to one another to build larger bodies. Atlas was one of these lucky survivors growing slowly in the twilight. It gathered the dust of dead stars, silicates, organic molecules and ices, and packed them into a body roughly half a kilometre wide. It was a time capsule being sealed. But why is it here? Why is it not still orbiting that distant star safe in its frozen cradle? The answer lies in the gravity of giants. The composition of Atlas suggests it formed in a system that was not peaceful. A system with calm, stable planets does not usually throw its children into the dark. To eject an object with the speed and trajectory of Atlas, you need muscle. You need the gravitational power of gas giant planets. We believe the home system of Atlas was similar to our own solar system in its early days, but perhaps more chaotic. There were likely massive planets similar to Jupiter and Saturn, moving through the disk of gas and dust. These giants did not stay in one lane. They drifted, migrating inward toward their star or outward toward the edge of the system. As these titanic worlds moved, their gravity acted like a snowplow. They disrupted the orbits of the trillions of small icy bodies forming in the cold zones. It was a game of cosmic billiards on a terrifying scale. Atlas was simply in the wrong place at the wrong time. We can reconstruct the moment of farewell. It happened roughly 4 billion years ago. Atlas was floating in its cold orbit, minding its own business when a gas giant passed nearby. The massive gravity of the planet grabbed hold of the small icy rock. It was not a collision, it was a gravitational slingshot. The giant planet stole a tiny bit of momentum from Atlas and gave it a massive kick in return. In a matter of hours, Atlas was accelerated from a gentle orbital speed to a velocity fast enough to escape the grip of its star forever. There is a profound sadness in this data. We are looking at an object that was violently evicted from its home. It was cast out by the very planets that were supposed to be its siblings. As the gas giant moved on, settling into a stable orbit, Atlas was flung into the void. Behind it, the home star grew smaller and dimmer until it was just another star in the sky. The warmth faded. The light vanished. Atlas entered the interstellar medium, the vast lonely ocean between the stars. For eons it drifted. The carbon on its surface was bombarded by high-energy cosmic rays, slowly turning the outer layer into a dark reddish crust. This is a complex organic sludge known as tholins. This dark coat acted as a shield protecting the volatile ices deep inside from evaporating. It became a dark wanderer camouflaged against the blackness of space. It passed through clouds of hydrogen gas. It watched the galaxy rotate around its center nearly 20 times. It saw other stars are born and die in the distance, but it remained alone, a frozen fragment of a forgotten history. The polarization data we see today is the result of that journey that lasted for billions of years. The roughness of the surface is the accumulation of microscopic impacts from interstellar dust, the weathering of deep space. Every pit and crag on its body is a scar from its long exile. When we look at the chemical makeup of Atlas, we are seeing the standard model of planetary formation. It proves that the ingredients for worlds such as water, carbon, and organics are not unique to our solar system. They are common. They are everywhere. Atlas is a messenger saying that the recipe for home exists across the galaxy, yet the emotional weight remains. This object carries the frozen memory of its birth. It holds the chemical signature of a nebula that dissipated long before humans walked the Earth. It is a ghost from a nursery of stars, bringing with it the chill of the outer rim. We have confirmed its origin. It is not a spaceship, it is not a weapon, it is an orphan. It is a piece of a puzzle that was thrown away before the picture was finished. And now for a brief moment it is passing through our warmth, whispering its story of cold creation and violent departure before it returns to the eternal night. We are the first to hear it, and likely we will be the last. For centuries we looked up at the night sky and believed that our solar system was a closed room. We thought that everything moving around our sun, the planets, the asteroids, the comets belonged to us. They were family members living in the same house. We assumed that the vast space between the stars was empty and silent, a dark ocean that nothing ever crossed. But recently the universe decided to open the door. In a very short span of time we were visited. We realized that the space between stars is not a wall but a highway. We witnessed 3 distinct wanderers, 3 different stories written in stone, ice and dust. They are Oumuamua, Borisov and Atlas. These 3 visitors are like guests at a cosmic dinner party. One sat silently in the corner, refusing to speak. One looked exactly like our own cousins. And one burst into the room with bright energy, only to shatter before the night was over. Together they teach us about the incredible diversity of the galaxy. The first traveler, Oumuamua, the silent mystery. The first guest arrived in late 2017. It appeared so suddenly and moved so fast that we almost missed it. Astronomers named it Oumuamua, a Hawaiian word that roughly translates to a messenger from afar arriving first. Oumuamua was shocking because it was undeniable proof that we are not isolated. It dropped into our system from the direction of the star Vega diving toward the sun and then shooting back out into the dark. But it was its nature that confused everyone. It was weird. It was incredibly strange. Most things that fall toward the sun heat up and release gas. They become comets with beautiful glowing tails. But Oumuamua stayed silent. It had no tail. It released no visible cloud of water or dust. It was dry dead and inert. When we looked closer at its light, we realized its shape was impossible to believe. It was not a round rock. It was elongated, stretched out like a cigar or a flat pancake, perhaps 10 times longer than it was wide. It was dark red, the color of organic molecules that have been cooked by cosmic radiation for billions of years. It tumbled through space, flipping over and over, silent and dark. And then it did something that gave scientists goosebumps. As it left, it accelerated. It moved slightly faster than gravity alone should have allowed. It was as if something gave it a gentle push. Was it a spaceship? Was it a piece of alien technology? Probably not. The push was likely caused by invisible gas escaping from its surface just enough to act like a tiny rocket thruster. But because we could not see the gas, Oumuamua remains a mystery. It felt like a monolith, an ancient artifact drifting through the void indifferent to our existence. It was a traveller that refused to share its secrets, the second traveller. Borisov, the familiar cousin. 2 years later, in 2019, the second interstellar visitor arrived. We braced ourselves for another mystery, another strange dark rock. But the universe surprised us again this time by being normal. This visitor was named Borisov. Unlike the dark and dry Oumuamua, Borisov was bright and active. As it got closer to the sun, it began to glow. It grew a beautiful ghostly tail of dust and gas. It looked exactly like the comets we see in our own solar system. This was a profound moment for science. For the first time we could analyze the blood of a visitor from another star. We looked at the light coming from its tail to understand its chemistry. We found water. We found carbon monoxide. We found rocks and dust. It was shocking because it was so familiar. Borisov taught us that the recipe for making worlds is the same everywhere. The same ice that sits in our Antarctica, the same dust that sits in your garden exists light years away around other stars. Borisov was not a mysterious artifact, it was a brother. It told us that while other solar systems might be far away, they are built from the same bricks as our own home. It made the galaxy feel a little less alien and a little more like a shared neighborhood. The third wanderer, Atlas, the intense tragedy. Then we watched the story of Atlas. While Oumuamua was the silent stone and Borisov was the steady ghost, Atlas was the dramatic firework. Atlas captured the world's attention with its intensity. As it approached the sun, it brightened with incredible speed. It became huge and luminous, glowing with a bright green color, promising to be one of the brightest sights in the sky for decades. It was aggressive and bold, it felt powerful. But the heat of the sun is a cruel test. Atlas was not a solid singular rock like Oumuamua. It was a loose collection of ice and dust held together by weak gravity. It was fragile. Just as it was about to put on its greatest show, Atlas fell apart. It crumbled. We watched through our telescopes as the heart of the comet shattered into pieces. The intense sunlight was too much for it. The mighty Atlas disintegrated, fading away into a cloud of broken fragments. It was a death in real time. Atlas represents the violence and fragility of space. It reminds us that these wanderers are not eternal. They are temporary. They fight against the gravity of stars and the heat of radiation. Some survive to travel for billions of years, and some like Atlas are destroyed in a fleeting moment of glory. The symphony of diversity. So what do these 3 wanderers tell us? They tell us that the universe is not boring. It does not produce just one type of object. Imagine walking along a beach. If you pick up 3 things, you might find a piece of smooth, dark sea glass, Oumuamua, a normal white seashell, Borisov, and a fragile sandcastle that collapses when the water touches it, Atlas. The Bisona dark sea glass of Oumuamua tells us that there are things out there we do not fully understand, objects that have been baked and twisted by the deep void until they look like nothing we have seen before. It represents the unknown. The seashell of Borisov tells us that there is a common language of chemistry. It represents the familiar. It gives us hope that if we travel to other stars, we will find water to drink and ground to stand on. The collapsing sandcastle of Atlas tells us about evolution and destruction. It shows us that planetary bodies are born, they live and they die. Space is a dynamic, violent place where things are constantly being built and constantly being broken. Conclusion: a busy sky. We used to think we were alone in a quiet house. Now we know that our windows are open. Oumuamua, Borisov and Atlas are likely just the tip of the iceberg. For everyone we see, there are likely thousands more passing by unnoticed in the dark. The space around us is full of fragments from other worlds. Some are shards of planets that were destroyed long ago. Some are icy seeds that failed to become planets. Each visitor carries a story from its home. Oumuamua might carry the story of a violent ejection from a dead star. Borisov carries the story of a wet icy system much like ours. Atlas carries the story of fragility. We are no longer just looking at our own reflection in the mirror. We are finally meeting the neighbours. And as we build better telescopes and as we learn to look deeper into the shadows, we must be ready. The next visitor might be even stranger than the dry cigar, even more familiar than the icy comet, or even more dramatic than the shattering giant. The galaxy is casting its stones across the dark waters of space, and for the first time we are awake enough to watch them skip across the surface. The show is over. The grand performance that captivated the night sky for weeks is drawing to a quiet close. The dazzling tail that once stretched across the heavens like a stroke of white paint is now shrinking, folding back into the darkness. To the naked eye, the comet is already gone. It has vanished from the casual view of the public, returning to the realm of ghosts and shadows. Now it belongs only to the most powerful machines and the most patient observers. We are witnessing the light curve drop steeply. This is the term astronomers use to describe how the brightness of an object changes over time. For a while that curve was climbing high, spiking as the comet rounded the sun. Now the line on the graph is falling. It is not a sudden drop, but a steady, relentless fading. Every night the object becomes a little harder to find. It is like watching a ship sail away into a thick fog. You know it is still there, but the outline becomes blurry until it is nothing more than a memory of a shape. The urgency in the control rooms of observatories is palpable, but it is a different kind of urgency than before. Weeks ago, the rush was to capture the sudden outbursts, the dynamic changes as the sun boiled the surface of the comet. Now the race is against the light itself. We are fighting to catch the last few photons, the tiny particles of light, before they become too few to count. The giant telescopes situated on high mountain peaks are swiveling, silently tracking the comet's retreat. The cameras are set for long exposures. The shutters stay open for minutes, sometimes hours, just to gather enough light to create a single grainy image. In these final images, the comet does not look like a majestic celestial wanderer. It looks like a faint smudge, a fuzzy dot among sharp stars. But these smudges are precious. This is the fading phase, and it holds secrets that the bright phase concealed. When the comet was bright, the massive cloud of gas and dust, the coma, was so thick it hid the nucleus, the solid heart of the comet. Now as the sun's heat weakens, that cloud is thinning out. The dust is settling. We have a brief window, perhaps only a few weeks, to try and see the solid rock beneath before it moves too far away to be seen at all. The scientists are tired. They have been working on shifted sleep schedules for months, but there is a sense of acceptance in the room. Nature dictates the schedule, not us. We cannot press pause. We cannot ask the comet to slow down. It is moving at speeds of tens of kilometers per second, rushing back toward the deep freeze of the outer solar system. There is a solemn respect for the laws of physics here. Gravity sped it up, and now gravity is slowing it down, but the momentum carries it away from us with an unstoppable force. As the distance between Earth and the comet increases, we measure the separation in astronomical units. 1 astronomical unit is the distance from the Earth to the Sun. Soon the comet will be 2, then 3 astronomical units away. The intensity of sunlight hitting it drops dramatically. It follows the inverse square law. This means that if the comet moves twice as far from the Sun, it receives only 1/4 of the light and heat. It gets cold very fast. We can see this cooling in the data. The spectral lines, the chemical fingerprints in the light are changing. When the comet was hot, we saw the signatures of complex molecules breaking apart. We saw water turning into steam. Now those energetic signs are quieting down. The graph lines are flattening. The outgassing, which is the venting of gas that creates the tail, is sputtering out. It is like watching a fire die down. First, the tall flames disappear, then the glowing coals dim, and finally there is just cold ash. The comet is entering its hibernation. The water ice is hardening again. The carbon dioxide is freezing solid. The surface is sealing itself up, locking away its secrets for thousands of years. There is a profound emotional weight to this departure. For a short time, this object united us. People all over the world stepped outside, looked up, and shared a moment of wonder. Now the sky seems a little emptier. The constellation where the comet used to be is just a pattern of stars, again missing its temporary guest. The darkness of space, which felt pushed back by the comet's brilliance, is reclaiming its territory. The data we are collecting now is the final chapter of a book we may never open again. We are measuring the rotation period one last time. We are trying to see if the comet spins differently now than it did before it met the sun. Did the jets of gas act like thrusters and change its spin? We are trying to calculate its orbit with extreme precision. We need to know exactly where it is going so that future generations, perhaps thousands of years from now, can predict its return. We are writing a letter to the future using numbers and coordinates instead of words, but even as we scramble to record these final numbers, there is a feeling of letting go. We have done what we could. We have pointed every sensor, every radar, and every lens at this visitor. We have terabytes of information stored in our archives. The anxiety of missing out is fading, replaced by the calm of analysis. The hunt is ending, the study is just beginning. The monitors in the observatory show a dark screen with a tiny crosshair in the center. Inside that crosshair is a faint pixel, barely brighter than the background noise. That is our traveler. It is passing the orbit of Mars. Soon it will cross the orbit of Jupiter. The sun from that distance is just a very bright star, not a warming orb. The comet is returning to the deep freezer of the Oort cloud or the Kuiper belt. It is going home. We watch it go with a mix of sadness and gratitude. Sadness because the beauty is fleeting. Gratitude because we were here to see it. The universe is vast and mostly static on human timescales. Stars live for billions of years, galaxies collide over eons. But a comet is dynamic. It changes by the hour. To catch one is a privilege. As the nights go on, the telescope time will be given to other projects. Astronomers will turn their attention to distant galaxies or exploding stars. The comet will be listed in the catalogues as a past event. But for those of us watching this fading light, the connection remains. We watch until the very last moment, until the magnitude number drops so low that the object blends perfectly with the black velvet of space. Eventually the command will be given to stop tracking. The telescope motors will whir and shift to a new target. The screen will refresh with a new image. The comet will be alone again, drifting in the silence, carrying the dust of its journey into the infinite dark. We turn off the monitors. We pack up our notes. The light has faded, but the understanding it brought us burns brighter than ever. We step out of the observatory into the cool night air, looking up at a sky that is once again still silent and beautifully, terrifyingly empty. And so the great show is over. The fire has faded. The magnificent glowing tail that once stretched across millions of miles of space has vanished, retreating back into the heart of the traveller. The heat of the sun, which woke the comet from its long slumber, is now just a warm memory fading fast as the distance grows. We are leaving the neighbourhood of the light. We are drifting away from the noise, the energy and the gravity of the inner solar system. The comet is no longer a screaming banshee of gas and dust. It has returned to what it has always been, a silent mountain of ice and stone floating in the velvet dark. Let us take a moment here in the crypt to understand what we have just witnessed. This journey was not just a random flight through the sky. It was a mission of cosmic importance. You see, this traveller is a time capsule. Locked inside its frozen chest are the secrets of the very beginning. The dust that clings to its surface is the same dust that formed the Earth, the Moon, and even your own body. Scientists tell us that billions of years ago, travellers just like this one rained down upon the young Earth. They carried with them gifts of ice which melted to become our blue oceans. They carried carbon and the tiny invisible building blocks that would eventually sparkle into the miracle of life. In a way, looking at this comet is like looking at an ancient ancestor. It is part of you. The iron in your blood, the calcium in your bones, and the water in your cells, it all shares a history with this lonely wanderer. We are all made of the same stardust dancing in the dark. Now the dance is slowing down. The comet passes the orbit of Mars, leaving the red planet far behind. It drifts past the kingdom of Jupiter, the giant guardian, without a sound. There is no wind here to whistle in your ears. There is no friction. There is only the pure, perfect silence of the void. Imagine that silence now. It is not an empty silence. It is a heavy, comforting silence. It is the sound of peace. It is the sound of the universe resting. The sun is no longer a raging ball of fire in the sky. It has shrunk to a bright, sharp point of light, just the brightest star among millions of others. Its pull is gentle now. It no longer commands the comet to hurry. It allows the traveller to drift, to glide, to float endlessly outward. The surface of the comet is cooling down. The cracks that opened up near the heat are sealing shut. The gas jets are sleeping. The heartbeat of the stone has slowed to a rhythm that matches the slow, deep turning of the galaxy itself. It is entering the great hibernation. Ahead lies the darkness. But do not be afraid of this dark. It is soft. It is like a thick velvet blanket wrapped around the shoulders of the world. It is the darkness of a safe room, the darkness of closed eyes, the darkness that cradles you before dreams begin. The journey does not end, it simply changes. The comet will continue to travel for thousands of years, moving deeper into the shadows further from the warmth. It goes to the frozen edge of the solar system, a place called the Kuiper Belt, and perhaps even beyond to the great shell of ice that surrounds our home. It goes where time has no meaning. In that vast emptiness, there is no yesterday and no tomorrow. There is only the eternal now. The comet floats in a state of suspended animation. It is perfectly preserved, perfectly safe, holding its secrets tight against the cold. It is a monk in deep meditation, untouched by the chaos of the planets, untouched by the worries of life. Feel that sense of suspension. Just as the comet floats weightless in the void, you two are floating. Your body is heavy, sinking into the mattress, but your spirit is light, drifting upward into the quiet. The gravity of the day is letting you go. The worries, the lists, the noises, they are all staying behind near the hot sun. You are travelling outward into the cool, calm peace of your own mind. The comet does not need to steer, it does not need to try. It follows a path laid out by the laws of nature, a path of least resistance. It surrenders to the drift. You can surrender too. You do not need to think about where you are going. You do not need to control the journey. The current of sleep is catching you gently, slowly pulling you away from the shore. Look back one last time at the centre of the system. The light is tiny now, a pinprick. And then you turn your gaze forward into the infinite black. It is beautiful in its simplicity. Just space, just peace, just quiet. The traveller is safe. It has survived the fire. It has survived the crushing gravity. It has returned to its home in this deep dark. It will sleep now for 10,000 years. And so must you. The story is finished. The science is done. The questions are answered. All that remains is the steady rhythm of your breathing, in and out, slow and steady, like the slow orbit of a distant moon. Good night, brave traveller. Good night to the stars that watch over us. Good night to the noise and the light. Drift on into the deep, cool shadow. Drift on into the silence. The universe is holding you. Sleep now. Sleep.